Of a parallelogram before we start anything today. Okay, here we go. Let's start off with 19, first property. Oh, good start. Good start. How about 19 again? Yep, of course. 10.
The sides across from each other.
Opposite sides congruent. There's one big one right there. Okay, let's keep it going. Here we go. 2. Opposite sides are parallel. Now let me stop there. Please focus in here. Please. Will just gave us opposite sides are parallel. If you have a parallelogram where a diagonal is already been drawn in, because the sides are parallel, what type of congruent angles do you have? Alternate interior. Please, please watch out for that if a diagonal is drawn in your diagram. And the same thing can be said for these two right here. Those are alternate interior. Please watch out for those. More properties. What do we have going on? 2, again. Opposite angles are congruent. Yep. Let's keep this train going with the fourth one, 9.
Diagonals bisect each other.
I like it. Diagonals bisect each other. And let's finish this strong. One more about the angles I'm missing. 4. There we go. Consecutive angles are supplementary. And are we all okay with what I mean by consecutive? Angle C and angle ADC. Okay? Consecutive. Consecutive angles are supplementary. All right, we're about to start using the parallelogram in our proofs now. I will let you know, just to save you some time, very rare that we use this one in our proof, this property in our proofs, that consecutive angles are supplementary. Very rarely. It's mainly these 4 that we're going to use into our proofs. All right. Just some comments before we start. You guys are going to, some of you guys are going to have to grind here. This is not going to be the easiest. Okay, here's why. Everyone remember when these were posted up back in Unit 2? They're coming back. Everyone remembers parallel lines. They're coming back. 5 different ways to prove triangles congruent. They're back. In addition to those properties we just went over. All in one proof. Okay, wait till the first one doesn't have it, but wait till we go over the second one. You will see all the different units already now in this one proof. Okay, so some of you guys, I'm just letting you know ahead of time, you're going to have to grind through this. It may not come easy. Even for the best of you guys, it may not come easy. All right, we're going to have to grind right through it. Number 1, I just put on there just to get your feet wet. All right, I believe it's a 3-step proof. All right, I did not try to just get to you right away. My suggestion, all these proofs we do today, you will be given a figure as a parallelogram. I would probably highlight which one is the parallelogram. Okay, in this case, we have 2 different parallelograms. WX TV. And we also have parallelogram ZYVT. Most of these proofs we do today, you're only going to be given 1, and it'll be easy to highlight that one, but in this case, we're given 2. And everyone take a look at what I'm asking you to prove. Side WX is congruent to side ZY. All right? One side in one parallelogram is congruent to a side in another parallelogram. Not a 2-step proof. Not a 2-step proof. So here's where you need to know your properties right now. Need to know your properties. Can you give me any fact about WX? Can you give me any fact about ZY right now? I'll take either side. Okay, not a two-step proof. They're not congruent because they're in two different parallelograms. Can you give me any fact about WX or about ZY? Let's do this. Let's get the show on the road. 11, anything you can say? Okay, problem though, we're dealing with congruent, so I kind of want to leave parallel out of this. It's just going to be extra steps. So you tell me, WX is congruent to what? VT. All right, WX congruent to VT. Everyone agree? Now, this is why I had you guys write so much on Friday. My reason, because what is WXVT or WXTV? It's a parallelogram, and I know a parallelogram implies what property? Opposite sides congruent. So I know that WX is congruent to ZY. Just leave it. I'll get it. Thank you. All right, anything else? You told me something about WX. Can you tell me anything about ZY, the other part of the proof statement? Anything about ZY, 17? It is congruent to VT as well, yes. I'm just going to put, hey, take a look. I'm just going to put it in the same statement because why am I going to write that reason all over again? All right, so ZY is also congruent to VT. Same reason. It's opposite sides are congruent. Now look at what you just wrote. Look at what you just wrote. WX congruent to VT, ZY congruent to VT. What do you got for me? An old one, an old one. Here we go. 8. What are you going to let me know?
WX congruent to ZY. Substitution.
There we go. I like it. Anything you want to ask here? Because now we're really going to get down and dirty. Anything on this first one? All right, let's go. Let's do this. What do we got next? Okay, there's that parallelogram symbol, so make sure you are fully aware which one's the parallelogram in the diagram. A, B, C, D. So all those 5 properties apply to what I just highlighted up there. And I gave you a couple more givens there. DF and EB are congruent. Okay, the proof statement doesn't look too unfamiliar. Proving those 2 triangles on the outside congruent. We've done that before. We know there's 5 methods to do so. Let's see. Sorry guys, I did not give you guys anything to work with as far as sides and angles go. So you got to help each other out now. Let's find some sides and angles. Finding some sides and angles now. You can use anything you want. I would always probably start with your properties of a parallelogram though. Start with properties of, is there any properties that I could apply to A, B, C, D that would get me sides or angles right now in those 2 triangles? Sides or angles. What are we looking at here? I'll take anything. Here we go. 3. What are we thinking here?
I'm thinking that DC equals AB. The opposite sides are.
Okay, hold on. Just something. DC and AB. Okay, I agree with that. Just so everyone's clear, is that going to give me a full pair of sides right now? No, but I'm assuming he's got a plan. Okay, so when I say AB congruent to DC, I'm going to use that, but just make sure you know it's not a full side in either of those 2 triangles. Parallelogram implies what, Sean? Opposite sides congruent, yep. So maybe some of you know where he's going with that. Maybe some of you see something else you want to tell me. Fine. Let's keep it going. 7.
Well, both are parallel. Obviously, we talked about parallel lines, but I don't know if that works with this.
Well, where are you going with your parallel lines, though? Usually they lead to angles being congruent. Okay. Are those the only two pair that are congruent? What's the other pair that's congruent? And aren't those full sides in? Okay, so that works. DA congruent to CB. All right, so you got a full pair of sides. Still looking for where Sean was going with his ABDC business. Okay, still trying to figure out where he's going. So we got a full pair of sides right there, DA and CB. All right, let's keep going. You can let me know where you think Sean was going or give me something else. 5.
Line DF minus DC is congruent to line DB minus AB.
Our old buddy that used to be up here, subtraction. Everyone see that? I'm going to take the given, subtract what Sean gave me to get this part. I'm going to take the given minus what Sean gave me to get EA. That's called a little subtraction now. Yep. So let's see. DF, I'm going to go on top first. DF minus DC equals on the bottom EB minus BA. Nice job, everybody. Subtraction. And then this isn't going to change no matter how many times we do it this year. After subtraction always came substitution. And that's to say that side EA is congruent to side FC. And that gives me a second pair of sides now. 1, 2, we're going to go 4, huh? Woo. Got it. All right, well, you need one more pair somehow. Now let's think about this, please. You guys, do we still know the 5 ways to prove the triangle is congruent? And you have 2 pairs of sides. So those 5 ways just got narrowed down to 2. What are the only 2 options I have to prove these 2 triangles congruent if I'm given 2 pairs of sides? Side, 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 or? Okay, so right now, here's where you're telling me. If you're going to go side, 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 you need to get these 2 congruent somehow. And if you go side, angle, side, you got to get those angles congruent somehow. This is where the tough part always comes in, is that darn third pair. Usually people can get the first 2 pretty quickly, but the third pair is a struggle. Remember, that's still a parallelogram. That is still a parallelogram. You have not used all the properties yet that you could have. All of you've told me is opposite sides are congruent. You have not used all the properties. What's up, Max? Okay, just let me show you where we're going here, everyone. Here's what Max just said. Opposite angles in a parallelogram are congruent. He is correct. I'll write that down. Angle DAB is congruent to angle DCB. Again, parallelogram implies. What property did Max just use? Opposite angles are congruent. But where is he going? Because those angles, I need to get those angles into the ones that are in my triangles. I need to go from here to there. Let me do that again. Here to there. Here to there. Used to be up there somewhere. Used to be up there somewhere. What's up, Mike?
Angle DAE is congruent to, or no. Angle DAB is supplementary to angle DAE.
Everyone agree with Michael's statement? These 2 are supplementary, so are the ones up top. What, Cameron?
I was going to say congruent
Okay, so they're supplementary. Let's go right there now. So list off those angles that are supplementary. Angle, go ahead, Mike, and name them off again. Angle.
Angle DAB is supplementary to angle DAE.
Okay, hold on. Supplementary to DAE. There's one pair on the bottom. And what about the pair on top? Angle.
BCD is supplementary to BCF.
I'm not going to go back to Mike because I think he knows. Anybody remember the reason why I know those angles are supplementary? It used to be up there. I believe it was in pink, I think. Emily? Why was it linear pairs or supplementary? Okay, so my final question to you guys is this. You know these two angles are congruent. This pair is supplementary. This pair is supplementary. So why are those two right now going to be congruent? It's another theorem that was up there with the rest of them. Go ahead, Justin.
Supplements to the same or to congruent angles are congruent.
Yep. Supplements of congruent angles are congruent. So we have angle DAE congruent to angle BCF. Supplements of congruent angles are congruent. And then hopefully you guys have enough info right now to say the triangles are congruent. So make sure you finish off your proof by saying the triangles are congruent by side angle side. What do we got? DAE, BCF. A little wake-up call, anybody? A little wake-up call. Here you go. Something in the past. Something in the past. Something in the past. Something in the past. Along with our new properties. Okay, that's where we are. That's where we're hanging around here the next couple days. I'm going to skip over 3 because I want to have you try one on your own. 4 is a little bit different, so I want to do 4 together right now. All right, let's do 4 together. My diagram got cut off. All right, let's do this. A, B, C, D. So the entire figure is a parallelogram. Got it. And I'm proving these two outside triangles congruent. Got it. But the entire figure is a parallelogram, so I can use all those properties. Oh, and I got a little midpoint action. Beautiful. You guys get me 2 pairs of sides or angles. I'll help you with the third pair. That's the deal right now we're going to make. Can you get me a pair of sides or angles, 2 of them, and I'll get you the third pair. I'll help you out with the third pair. All right, remember, entire figure is a parallelogram. Any sides or angles you know are congruent right now. 6. DF, okay, here's the problem I have. DF, not a side. Okay, so I'm not going to use that. All right, I'm not putting DF congruent to FC when FC is a side and DF is not. So that's not going to help me out too much. Is there any other sides or angles up there you know are congruent? Full sides, full angles in the triangle. 13. Here we go. 11. Everyone see angle A and C, full angles in the triangles, also opposite angles in the parallelogram. Angle A congruent to angle C. Parallelogram implies what property? Opposite angles congruent. There's a full pair of angles. Anybody have anything else for me? 6. What do we know about opposite sides in a parallelogram? Okay, so name me a pair of opposite sides that are also sides in the triangle. CD and? Okay, CB, congruent to DA. Everyone's all good with that? Parallelogram implies opposite sides congruent. That was pretty quick. I got you 2 pairs of sides and angles. You need 1 more pair and we're done. Sorry, Nate. That was pretty quick. Any questions right now where we are? Because we're about to get real nuts. Ready to go? Okay. What givens, I should say, have we not touched? The whole midpoint deal, right? Haven't even touched them. What's the midpoint? What's E doing to AB? Cutting it into half. Oh, okay. What's F doing to DC? Oh, geez. Way back in the day, when we cut 2 segments in the same diagram in half, or 2 angles in half, anybody remember the theorem we usually said, ding, 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 got to use? Everyone remember, halves of equal quantities are equal. Once 2 segments or 2 angles are getting cut in half in the same diagram, I want to use halves of equal quantities are equal. Question, name a segment that's about to be cut in half in this diagram. Name the other segment that's about to be cut in half. Halves of, have I said that those 2 are equal? But are they in the diagram? Why are AB and DC equal in my diagram? Here we go, 5. Okay, so what I'm going to do right now, so I don't have to do a new statement and reason, I'm just going to say AB, what I'm cutting in half is congruent to DC, the other one I'm cutting in half. They have to be equal before you cut them in half. Now let's cut them in half. You finish the story for me. Ready? AB. I'm cutting it in half. Half of AB. What's it going to be equal to? Half of AB. Half of AB. 9. Half of AB on my diagram is what? No. I don't want that. I want half of AB is equal to what line segment? AE. Why did Justin give me AE? Because he could have easily given me EB and he would have been correct. I don't care about EB. All right, thank you, Will. AE is the side in the triangle. Take half of, what other segment are we taking half of? DC. Let me know a little something. What's half of DC now? Name the line segment that's half of DC I care about. 1. Yep, FC. Guys always make this mistake, not by halves of equal quantities, though. What told us at the very beginning? Oh, you're going to take half of AB and you're going to take half of DC. Definition of a midpoint. Now we're ready. Ready? What's the theorem say? Halves of, that's what I have. I have halves of equal quantities are equal. So what can I say now? AE is congruent to FC. Halves of equal quantities are equal. And that should give you your pair. Method. Side angle, side. Whew. We okay? I am going to not let you go fully on your own yet, but on the one we skipped over, number 3, I want you and your group right now. You are proving triangles congruent again. Find me 2 out of the 3 pair, please. If you can find the 3rd pair, awesome, but try to find 2 out of 3 pair that would make the triangles congruent. And then we will talk. Try to find 2 out of 3 pairs of angles or sides that make the triangles congruent. And if you can find a 3rd pair, go for it. That's going to be the toughest part. Okay, let's see who we have right off the bat. 9. Where's a pair of sides or angles?
AD equals CB.
Okay, AD, pair of sides in both triangles. I like it. Why is that true, Justin?
Parallelogram implies opposite sides are congruent.
All right. All right, pair of sides from Justin. How about another pair from somebody? It's 2, another pair.
Angle BEC.
Not yet.
Say the right.
Got to say the right angles. Good catch, Will. So I can say angle F and angle BEC are right angles. Perpendicular lines form right angles. Then I can say they're congruent. Angle F congruent to angle BEC. All right angles are congruent. Whew. And then the tough part. Is everyone all right on this part? Because we got to get some help if we're not all right up to this part. I understand not finding the 3rd pair, but I don't really want to give it to you. In an enriched group like this, I really don't want to give it to you. Remember, you need a pair of sides or angles, remember, in those triangles. That's where you can start. I need some angles or some sides in that triangle. And let's narrow it down a little bit. Remember, there are 5 ways, right? Watch how we can just narrow this down pretty quickly. Everyone ready? Is it going to be side, side, side? No, because I was given I got an angle. Is it going to be side, angle, side? No, here's why. If I get that side, that angle's not in between. If I get that side, that angle's not in between. Everyone see that? There's no chance it's going to be side, angle, side. Could it still be angle, angle, side? Okay, angle, side, angle? Well, take a look. If it's angle C, is that angle, side, angle? If it's this angle, is it angle, side, angle? Could it be HL? Okay, could be. So you're down 2 out of 5 right now. It's pretty good. Okay, you went from 20% to 50% right now. Right, not bad. Okay, where is it going to come from? Anybody? I'll open it up to you guys. Yep.
I might have an idea. Angles BCB and angles CBA are complementary.
Say that again. DCB and
Angles BCB and angles CBA are complementary.
everyone agree with their statement? It's a product. Yeah, product. Property. Everyone agree? It's a property of a parallelogram. It's the one I told you we'd rarely use, but Nick's using it now, which is fine. And then where are we going from there? Everyone see it? So here you go. These 2 are this angle supplementary to C. This angle supplementary to FDA. Why would these 2 be congruent? Because supplements of? No, not of congruent angles. Supplements of the same angle are congruent. That's one way. One way. There's a couple other ways to get to those 2 angles. Because these are going to be the 2 angles. I'm going to let you know right now. Those are going to be the 2 angles we're proving. Whether it's by Nick's method or, ready, here's another way to do it. Take a look. Not only are these sides congruent, but they're also parallel. Everyone agree? And don't do this on your diagram because it'll be a mess, but here are my parallel lines cut by this transversal. Anybody remember what I call those type of angles right there, where I take this 4 and bring it down? Corresponding. What do you know about them? Congruent or supplementary? Congruent. Okay? There's even a third way, and you're going to pick which way to do it. I'm going to let you go on your own. Here's the third way, other than mine and Nick's way here. What do you know about these sides right here? They're parallel. What type of angles are these right here? Alternate, interior, they're congruent. And then what do you know about opposite angles? So if these two are congruent because they're opposite, these two are congruent because they're alternate interior, why would these two now be congruent? Substitution. So it's totally your call right now how you want to finish it. A lot of different ways. Supplements of the same angle. You can go corresponding angles, or you can go alternate interior with the substitution. If you do go the corresponding or the alternate interior route, tell me which lines are parallel first. All right, you can't say they're congruent until you tell me what lines are parallel. I'm going to go with my corresponding one, AD parallel to CB. Parallelogram implies opposite sides parallel. Angle C, congruent to angle ADF. Parallel lines imply corresponding angles congruent. And then that should give you, however you got C and ADF congruent, that should give you a third pair now. And then what's my reason going to be? HL or angle, angle, side? Okay, that shouldn't be that tough right there. Angle, angle, side.